am going to discuss about vector algebra. Position vector of a point. If a point O is fixed as the origin in space or plane and P in any point, then OP is called the position vector of P with respect to O. A vector in terms of position vector of its endpoints. Let A and B be the position vector of points A and B respectively. Then A and B be the position vector of points A and B respectively with respect to O. Then OA equal to A vector and OB equal to B vector. Then from triangle OAB, we have OA plus AB equals to OB according to triangle law of addition. OA plus AB equal to OB. Now AB equal to OB minus OA. Now OB is B vector, position vector of B with respect to O, and OA is position vector A with respect to O. Therefore AB equal to B vector minus A vector. Position vector of B vector minus position vector of A vector. Section formula. Let A and B two position points. A and B be 2 points with position vector A and B. Position vector, I write here position vector as P dot V. Position vector A and B respectively. And let C be a point. C be a point dividing AB internally. In the ratio M is to N. Then position vector of C is given by OC equals to M B vector plus N A vector by M plus N. The proof. Let O be the origin. Then OA vector equals to A vector and OB equals to B vector. Now let C be the position vector. C be the position vector of C which divide AB internally in the ratio M is to N. Ratio M is to N. Then AC by CB equals to M by N. Now implies MAC equals to MCB. This is AB vector. This is C. C vector divide AB in the ratio m is to n. This is m, this is n. Therefore, AC by CB equals to m by n. Now, AC vector equals to C, position vector of C minus position vector of A, and CB equals to position vector of B minus position vector of C. Now NC vector plus MC vector equals to MB vector plus NA vector. Therefore, C vector equals to MB vector plus NA vector by N plus N. Hence, the position vector of the point C is this. If C is the midpoint of AB, then C divides AB in the ratio midpoint means 1:1 ratio. Therefore, if we put 1 in the place of M and 1 in the place of N, then position vector of C equals to A vector plus B vector by 2. Theorem 2. Let A and B be 2 points with position vector I have written here in P dot V, A vector and B vector respectively. And let C be a point dividing AB. C be a point dividing AB externally in the ratio M is to N. In the ratio M is to N. Then position vector of C is given by M B vector minus N A vector by M minus A. Proof. OA vector proof. OA vector equals to A vector, OB vector equals to B vector, and OC vector equals to C vector. Then AC by BC equals to M by N. Means this is A, B, C. C vector divides AB in the ratio m is to n external. Therefore, AC by BC equals to m by n. Now, NAC equals to MBC. Now, AC, the position vector of C minus position vector of A equals to M position vector of C minus position vector of B. Therefore, M plus N C vector equals to N A vector minus N B vector. N minus C vector equals to N A vector minus N B vector by N minus C. Now let's consider an example. 4 points A, B, C, D with position vector means P dot P. A, B, C, D respectively are such that 3A minus B vector plus 2C vector minus 4D vector equals to 9 vector. So that 4 points are the 4 points are coplanar. Also find the position vector of the point of intersection of line segment AC and B. Solution. We have, according to question, we have 3A vector minus B vector plus 2C vector minus 4D vector equals to 9 vector. This implies 3A vector plus 2C vector equals to B vector plus 4D vector. The sum of the coefficient on both sides of the above result is 5. Coefficient of A vector 3, coefficient of C vector 2, 3 plus 2 5. And here coefficient of B vector is 1 and B vector is 4. Therefore 4 plus 1 5. Now if we divide both sides by 5, then we get 3A vector plus 2C vector by 5 equals to B vector plus 4D vector by 5. Now 3a vector plus 2c vector, we can write 5 in terms of 3 plus 2 and here in terms of 4 plus 1. Therefore, according to section formula, position vector of a point P, this implies position vector of a point P dividing AC in the ratio 2:3, and position vector of a point P dividing BD in the ratio 4:1. Therefore, P is the common point. Of AC and BD. Therefore, AC and BD intersect. AC and BD intersect each other. Therefore, ABCD are coplanar. Therefore, A, B, C, D are coplanar. AC, P dividing AC in the ratio AC in the ratio 2:3 and BD in the ratio AC in the ratio 3:2, 2:3 and BD in the ratio 4:1. According to section formula. Please subscribe my channel and if possible then like. Thank you.